Okay, guys. We're going to do some more factoring today. So I'm going to first work with you and recall how to factor a nice little simple quadratic trinomial here. Obviously we've done this. These were the factoring ones that you really liked. Thought they were pretty simple. We're going to factor polynomials that are similar to quadratics, but they're not going to be quadratics. Okay? Remember, quadratic means a degree of 2. Okay? We're going to have higher degrees than that. Okay? But, real quick, how do we factor this quadratic trinomial again? What's our thought process? What's going through our head? Greatest common factor, first of all. Absolutely. Always, always, always greatest common factor. Does this trinomial have one? No. The number 1, but we're not going to pull out a number 1. Okay, what two numbers multiply to 14, add to -9, right? Okay, because it's just a 1x squared, so then you can kind of already break it down. You know, x times x gives me x squared, and then the two numbers that multiply to 14 and add to -9 would be what? -7 and -2, and you're done, right? Remember that a little bit? Okay, so quick review, factoring quadratics. The ones we're going to do are going to be very similar to that for the most part, but they won't be quadratics. So, here we go. Here's the first one. X to the 4th minus 5x squared minus 14. Okay? It's very similar. It's a trinomial. The degree on the first term is double the degree on the middle term, just like the previous one was, and then you have a constant at the back end. So it is still going to work pretty nicely, but instead of starting x times x, guess what you're going to start? X squared and x squared. Because x squared times x squared, if I were to multiply these factors back together, x squared times x squared is going to give me x to the 4th. The last part works the same. What two numbers multiply to -14, but add to a -5? -7 and a +2. Okay, you are done in this case, yes. Yep.
Equal to 0.
Look at the directions.
This factor.
And there is not a 1. Not an equal sign. Okay. Directions would have to say solve if you're going to set them equal to 0, and there would have to be an equal sign if you're going to be able to solve. So you'd be done when it just says factor. Okay. You're like, well, that's pretty simple. Yeah, it is. Okay. It is going to be very simple. But I'll prove it to you that it's still the same. X squared times x squared is x to the 4th. X squared times 2 would be a positive 2x squared. -7 times x squared would be a -7x squared. So you had a positive 2x squared and a -7x squared, which add together to make -5x squared, and then -7 times 2 gives you -14. Okay, pretty simple. Okay, try this next one. Very similar. What do you think you got?
X squared minus 11. X squared plus 2.
They got to multiply to 20.
Minus
X squared
5.
minus 5, x squared minus 4.
X squared minus 5, x squared minus 4. However, on this one, you're not done. One of those can be factored further.
The 4.
X squared minus 4. That is the difference of two perfect squares. What does x squared minus 4 factor to?
X.
X plus 4. X minus 4.
Not quite.
X minus 2, x plus 2.
X plus 2, x minus 2. Yep. Remember the old difference of two perfect squares?
Do we do one parentheses x plus minus 2? Or do you want to do it
No.
separate?
Yep, write them separately. Yep. With solutions, that's fine, Creighton, but not with factors. Leave factors
Separate?
separate. Yep. If this was a solve problem, if this said equal to 0 and it said solve, then here you'd get x equals -2, here you get x equals +2. So then you could write x equals plus or minus 2 in your solutions, but I don't want you to do that for factors.
Okay.
Okay? Okay? Yes, so far? Any questions? Okay? Keep moving forward there a little bit. Okay? 9x to the 4th minus 12x squared. Thataway, Chris. Take out the greatest common factor. If there's a greatest common factor, you need to recognize that right away. Always, always, always take out the greatest common factor. What will it be?
3x squared.
3x squared. You guys are rolling on this.
What if there wasn't a greatest common factor?
Then, I mean, if there wasn't a greatest common factor, I don't know that this one necessarily would even be. I mean, there is a greatest common factor because they both have x's in it. But like, so, let's say you had something like 10x to the 4th plus 7. Okay, there is no greatest common factor, right? So basically then it's not factorable. You just say not factorable. Okay? So 3x squared, what would be left?
3x minus 4.
3x squared.
3x squared minus 4.
4.
Can we factor it any further?
No.
Not quite. This one's almost a difference of two perfect squares, but what part of this one does not make it a perfect square?
3.
The 3, yep. If this was a 25x squared, then I could. If this said 25x squared minus 4, then how could I factor it further? 5x plus 2, 5x minus 2. Yep. Okay, but it's not, so you're done. Okay? Next one, really not much different. It's still very much like all the others. You got a power here on the first term. The power on the middle term is exactly half that of the first term. So now instead of starting with x and x, or instead of starting with x squared and x squared, we're going to start with
X
cubed. X cubed, because x cubed times x cubed makes x to the 6th. And then what two numbers multiply to -15 and add to a -2? -5 and +3. Can I go any further?
No.
No. If the 5 or the 3 were a perfect cube, then I could use the rules that got erased by our janitor. A cubed plus b cubed can be factored to a plus b, a squared minus ab plus b squared. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Okay? So, had the 5 or the 3 been a 1, or an 8, or a 27, or a 64, or a 125, had any of those numbers been a perfect cube, you could have used the sum and difference of two cube rules, okay, that you see over there. You could have used either of those rules to factor it further. But in this case, you can't, so you're done. So far, so good? Awesome. Next. Thoughts on the first one?
Take out a 1x.
Greatest common factor would be x. That would leave me with 3x to the 4th minus 2x squared minus 8. So now it at least looks good here. You got x to the 4th and you got an x squared and then you got a constant. The bad thing is this one's got a coefficient in front of that first term. It's not just x to the 4th. So this is where some of you would guess and check. Some of you would go to your box method. I'm going to show you maybe even factoring by grouping. Okay? So those of you that would have gone to the box method, you would have taken 3 times -8, which is -24, and you would have put that number here, right? And then you would have put the b value right here as -2.
Yeah.
What two numbers multiply to -24 and add to a -2?
-6 and +4.
-6 and +4. So then, if you want to factor by grouping, instead of using the box method, watch what I do here. 3x to the 4th minus 6x squared plus 4x squared minus 8. See how I use these two numbers to create my -2x squared? Yes or no? Okay. And now I'm going to factor by grouping. I'm going to run out of room. What do these two terms have in common?
That's 3x squared.
3x squared, right? What would be left?
X squared.
Minus 2. And what do these last two terms have in common? 4.
4, yeah.
So plus 4, and what's left in the parentheses?
X squared minus 2.
X squared minus 2. So do we see, you see how I factored by grouping, similar to that assignment that you guys did for today? So now final answer, x, 3x squared plus 4, and x squared minus 2. So that one's tough. It's combining a whole bunch of things. It's combining a greatest common factor. It's combining using a different factoring method. It's not just simple, what multiplies to this adds to this. That doesn't work anymore because there's a coefficient on your leading term there. Instead of the box method, I showed you factoring by grouping, but you're welcome to use the box method. You're welcome to guess and check. Questions on that guy? That's probably as tough as they would come. All right, we'll keep going. Next one, first step. Greatest common factor. 6 what? X in. Then I have x to the 8 minus 5 x to the 4th minus 50. I like what's in the parentheses a lot better this time. What times what gives you x to the 8? X to the 4th. And then what two numbers multiply to -50 and add to a -5?
-10 +5.
-10 and +5. And I believe you would be done. Okay? Any questions on those two? And I got 2 more that should go pretty fast. X to the 4th minus 81. That is the difference of 2 perfect squares. What are my factors? Plus 9 and x squared minus 9. But are you done?
No, you can add X plus 3, X minus 3.
X squared minus 9 is also the difference of two squares. So that one becomes x plus 3, x minus 3. Difference of two perfect squares, those will show up, so keep on a lookout for those. The difference, so it's got to be subtraction of two perfect squares, the subtraction of two perfect squares. The sum of two perfect squares can't factor any further. Okay. How about this guy? Are they both perfect squares?
Yeah.
Yeah. What times itself makes x to the 10th?
Oh,
X to the 5th. What times itself makes 16?
4.
4. So what are my two factors?
X plus X to the 5th plus 4. X to the 5th minus 4.
Can I keep going?
No.
No.
Yes.
X to the 5th, is that a perfect square?
No.
No, because what times itself makes x to the 5th?
Not 5th.
X to the 2.5, if you're a real smart aleck, you would have said that. Okay? Well, we're not gonna mess with that. We're not gonna mess with fractional powers. Okay? So you'd be done. You'd be done. Okay? So, I just tried to show you a lot of different possibilities. What I would like, I want week 8. Under week 8, I want you to start with these 1 through 25 odds. Those would be really similar to what we just did in class. So I want you to start working on that. Then this 1 through 18 is it's a factoring practice that combines everything. Okay? It'll be challenging. Okay? It'll be challenging for you, but we got some class time we'll spend on it. We'll talk about some of them together. Okay? So, on this one, on 1 through 25 odd for tomorrow, I know we're down to about 8 minutes. Try to get at least 1 through 9 odd done for tomorrow. Okay? 1 through 9 odd done for tomorrow, starting right here. Okay? I think they'll go pretty fast. Some of you will probably have them done in these 8 minutes. It shouldn't take you too, but at least I'd like to see everybody get 1 through 9 odd done for tomorrow. If you can get more, that just means you potentially will have more time off later in the week. Okay?